All right, so let's do a few more applications of proportions. And now we're looking at similar triangles. So those are triangles that have the same angles. And in this chapter, we're going to be looking at shadows. So we have a 2-meter tall man. So this is here's our 2-meter tall man here. Okay. And he casts a shadow that's 3 meters long. So this distance from the man is 3 meters. Okay, sun's up here. Right, and so the distance of that shadow is 3 meters. How tall is a tree that casts a shadow that's 30 meters long? So now we have a shadow that's 30 meters, and we want to know this distance here, this height. Okay, I'll call it h. So we're looking for the height of the tree. Well, that sun is blocking, or the shadow is like the sun's blocking on the same angle. And so we can figure out what that height of that tree must be, because these are going to be equal proportions. So what we can do is we can look at the object over the length of the shadow. So in this case, we have a 3 meter, no, sorry, a 2 meter, 3 meters would be a very tall person. We have a 3 meter tall object, which is casting a shadow that is 3 meters. Okay, we know that's going to be an equal proportion to a tree, which is X meters tall, and casts a 30-meter shadow. So now we can do our cross product. And we would say 2 times 30, or here, 2 times 30 equals 3 times x, or 3x. 2 times 30 is 60, so we have 60 equals 3x. Now we're going to divide both sides by 3 to get rid of that coefficient in front of the x, and that gives us x equals 20. So we would say the tree is 20 meters tall. Okay, this next one is much the same. So you're going to be looking once again at a proportion of object over shadow. This time you have a mixed number, so make sure you convert that to an improper fraction first, and then see if you can solve for the unknown. So pause this video and give this one a go. All right, so let's try this one together now. So we're looking for object over shadow. So we're told we have a 5.5 foot tall woman who's casting a shadow that is 3 feet long. And then we have a building. We don't know how tall it is, so it's our object we're looking for, that casts a 90-foot shadow. So if we do our cross product, we're going to have 3 times x, or 3x, equals 5.5 times 90. So let's convert that 3 or 5.5 to an improper fraction. So that's going to be 11 over 2. And then we're multiplying that by 90. Remember, 90 is really 90 over 1. I'm going to do some cross simplification there to divide the top and bottom by 2. And so I'm going to get 3x equals 11 times 41. Nope, 11 times 45. And that's 495. That's over 1, so it's just a whole number. So we get 495. Now we want to know what a single x is. So to isolate my x, I'm going to divide both sides by 3. And that gives me, so on the left, they just cancel out, and I'm left with x equals 495 divided by 3 gives me 165. So that means the building is 165 feet tall. Okay, let's take a look at these next two. So these are dilution questions. And if you happen to be going into nursing, these ones will be particularly useful to you. Okay, so in preparation for testing, we often need to dilute a solution. The dilution ratio is going to be the ratio of the volume that you use in your original solution to the total volume of the diluted solution. So if we want to know how much water is required to make a 1 in 20 dilution from 8.5 mils of serum. So our 1 in 20, that's like our original amount. We could call it original concentrate, original amount over the total volume of the dilution. Okay. I guess I could say original volume over total volume. Okay, so our original volume here then is 1. Our total volume is going to be 20. We want to know how much water is required to make a 1 in 20 dilution from 8.5 mils of serum. So our original volume of serum then is 8.5 milliliters. Okay. That means our X here is going to be the total volume of dilution, let's say. Okay, so let's solve for the total volume of dilution that we're going to have if we use 8.5 mils of serum. Okay, so we're going to do the cross product method, and that's quite convenient because we have 1 times X, which is just X. So we almost are solved already, equals 8.5 times 20. So if we do that multiplication, 8.5 times 20, we get 170. But wait a sec, this is going to be mils. We were asked how much water is required to make this dilution. So now we know that the total volume of the dilution is 170 mils. Once we're done, we're going to take our 8.5 mils of serum. We're going to add enough water to get a final volume of 170 mils in our diluted solution. How much water did we need to do that? So we know that the amount of water plus the amount of serum is going to equal the total volume. So in this case then, the amount of water plus 8.5 mils of serum equals 170 mils total. And so to figure out the amount of water, while we added 8.5 here, we can actually subtract 8.5 from both sides, because the amount of water added is going to be our total water volume, or our total volume of 170 minus that original volume of serum. And so then we're going to get our water equals 170 minus 8.5, which is 161.5 mils. So 161.5 mils of water is required. So these ones are a little bit tricky in that you have to think about what is being asked here. So we have a dilution that gives us the original volume over the total volume. But if you're asked how much diluent or water is required to make that dilution, that means you're going to have to calculate how much volume you had from your original concentrate, from your 8.5 mils of serum in this case. So try another example. So in the second case, then you're looking for how much water is required to make a 3 in 50 dilution from 11.25 mils of serum. So go ahead and pause and try that one. Okay, so hopefully you had a chance to try this. So once again, we're going to be looking first at our original volume over our total volume. And so our dilution is 3 in 50, which means 3 is our original volume. 50 is going to be our total volume at the end. And so we have 11.25 mils of serum. That's our original volume of serum. And so this X down here is going to be our total volume of our dilution. So serum plus water, total volume of dilution. So let's solve for x. So we get 3x equals 11.25 times 50. So let's do that multiplication. So 11.25 times 50. So I get 562.5. And then we're going to want to divide by our coefficient. So divide by that 3. And we'll get 1x, or just x, equals 562.5 divided by 3 gives me 187.5, and we're dealing in mils. So that's the total volume of this dilution. So now, so this was kind of like step 1. So step 2 is to figure out how much water we need. So we know our water plus our amount of serum is going to equal our total volume. So the amount of water plus our serum was 11.25 milliliters, must equal 187.5 milliliters. So we can subtract 11.25 from both sides of this equation. We're allowed to do that as long as we do it to both sides. Then I'll have plus 11.25 minus 11.25. So it's just going to go away on the left. And so I get the amount of water equals 187.5 minus 11.25, which gives me 176.25, and this is in mils. So 176.25 mils of water is required.